This is section 9.3. So in this section we're going to take these radical expressions and we're going to rewrite them as exponents. So we can write these roots or these radicals as rational exponents. Now rational just means like ratio, or it's another word for fraction exponents. So for instance, the square root of x can be written as x to the 1/2 power. The cube root of x can be written as x to the 1/3 power. The fourth root of x can be written as x to the 1/4 power, and so on. This little number out here, remember, is called the index. This root symbol is called a radical. The stuff under the radical is called the radicand. Okay. Now you can see how I kind of accented this, that cube root is, found over here in the denominator. Sorry, I lost my train of thought there for a hot second. That this fourth root is down here in this denominator, fifth root down here. Now you might be saying, well, where did that 2 come from? Well, remember, because this is a square root, there's an understood 2 right there that we don't have to write. So if there's no index written, we assume that it's a 2, that it's a square root symbol. So, okay, so let's break out the calculator and do a few examples. So pause the video, grab your calculator out, and let's just do some examples. Okay, so 36 to the 1/2 power. Now that's the same thing as the square root of 36, but let's do it in exponent form here. So 36, then we know this little up arrow is my exponent button. Now while in that exponent, I can hit the fraction button and then do 1, go down, and 2. So I get 36 to the 1/2 power, which is the same thing as 6. So remember, it's the same thing as the square root of 36, so we should have gotten 6. So let's do negative 25 to the 1/2 power. Now let's make sure we put those parentheses. So parenthesis, negative 25 raised to the 1/2 power. And we get a domain error. So what is wrong with that? That's because the square root, the 1/2 power, of a negative number is a non-real answer. It's going to be an imaginary answer. If we redo this and we don't put the parentheses around it, so if I were just to go back through here, I'll just delete those parentheses off, I'm going to get negative 5. That's because this negative is not part of the 1/2 power. This negative is on the outside of that radical, so it's just along for the ride. All right, so grab your calculator and then see if you can do these on your calculator. So pause the video and see if you can do those on your calculator. The parentheses are important. So if we did parentheses, negative 64 raised to the 1/3 power, get negative 4. Okay, that's the cube root of negative 64. We can take a cube root of a negative. We can't take the square root of a negative yet. And then this fraction. So we're going to put the parenthesis, then hit the fraction button. 1/81. We're going to get out of the fraction, out from under that denominator, close the parenthesis, then hit the exponent, hit fraction again, so we can do the 1/4. So we get 1/3. That's because that's the fourth root of 1/81. The fourth root of 1 is 1, and the fourth root of 81 is 3. But I just want to show you how that would go down on the calculator. Okay, so back in Math 90, if you guys had Math 90 recently or something equivalent, we learned a whole bunch of exponent rules. So let's review those rules. Okay. So if A and B are non-zero, M and N can be any rational number. So we have these exponent rules, which I numbered just to make it easier to reference in the future. So when I do examples now, I can just say, hey, this one, rule number 1, rule number 4, so that way you know which one I'm using. All right, the first one. We don't want to say anything to the 0 power is 1 because 0 to the 0 power is not 1. It is an indeterminate form. But anything non-zero to the 0 power is going to be 1. When you multiply with the same base, you can add the exponents. Similarly, if you divide with the same base, you can subtract the exponents. Whenever you have a power raised to a power, you multiply the exponents. And then this kind of distributive, almost looking rule here says that the product raised to a power is the same thing as the product of those powers. And same thing with division here. Last up are the negative exponent rules. It says if you have a negative exponent here in the numerator, you can move it to the denominator. And the exponent will become positive. If your negative exponent is in the denominator already and it's down here negative, move it to the top and it'll become positive. So I did type these up in D2L and on my website. I have these typed up for you so you can print this out and just have it handy whenever you're doing the homework, quizzes, tests, and all that stuff. Alright, so let's talk about a new exponent rule, and that's going to be number 8. I didn't actually have to put number 9 on there, and I'll explain that one later. This is a special case of number 8, but number 8 is the one I'm about to talk about. So this rule says that if you have the nth root of something to the m power, you can rewrite it in this rational form, rational exponent form, as m over n. Now, what this means is, remember how we have the nth root can always be the 1 over n power. Like the 4th root was the 1/4 power. The square root was the 1/2 power. So if I rewrote that as the 1 over nth power, and I use exponent rule number 4 that says I have to multiply these, I'm going to multiply m times 1 over n, and it's going to give me m over n. So that's where that comes from. It comes from the definition of these, of rewriting these radicals in terms of exponents, and then using that exponent rule number 4 that says if you have a power raised to a power, you multiply. So a lot of students tell me that they find it helpful to think of this rule as exponent over root. That helps them remember which one goes on top, which one's bottom. The exponent is on the top, the root is on the bottom. So this means the cubed root of 8 squared can then be written in exponent notation as 8 to the 2/3 power. Exponent over root. You can use the calculator to do 8 to the 2/3 power. So if I want to do 8 and then the exponent key, then the fraction, 8 to the 2/3 power is 4. So this cube root of 8 squared is what's called radical notation because there's a radical. So you can see how I accented the word radical and said, look, here's a radical symbol. 8 to the 2/3 power is exponent notation. So just so you know, if Hawks asks you for it in exponent notation versus if Hawks asks for it in radical notation, you'll know which one they're asking for. Okay, so let's look at some examples. If we have x to the 3/4 and I want to write this in radical notation, remember this is exponent over root. That means I'm going to have a 4th root and an exponent of 3. Right? Easy peasy, right? As long as you remember which way they go, so you don't accidentally put the 3 here and the 4 here, because that does make a totally different problem. Alright, so x to the 5/2, exponent over root. So that's a square root and a 5th power. remember the square root doesn't have it has an index of 2, but we don't write it. So it doesn't have a written index there. So that 2 doesn't have to be written here. It's not wrong if you do write it, it's just not necessary, and Hawks will tell you to simplify your answer further if you try to write it. Alright, so what about x to the 1/5 to the 5/7? Well, to start off with, we're going to use exponent rule number 4. So which one is that? This is the one that says if you have a power raised to a power, you multiply the exponents. So I'm going to multiply those exponents together. 1/5 times 5/7 is 1/7. I did that without a calculator, but if you want to use a calculator, you certainly can. So I end up with this product simplifying to just be 1/7, which is exponent over root. That's the same thing as the 7th root of x to the first exponent, the first power. Now, Hawks does not like unnecessary ones. So if you try to write it like this, Hawks is going to tell you to simplify your answer further. So that means you just need to write it without that 1. Alright, so let's see another one here. Here we've got 4x to the 3/4 power. Rewriting this, because this is all in parentheses, all of that is going to be under that radical symbol. So I'm going to have exponent over root. So there's my root, there's my exponent. Notice how I put parentheses around that 4x. Now I can simplify that using exponent rule number 5. That's the one that says if you are multiplying and raising that product all to a power, that you can almost kind of distribute that power. It's not really distributing, but that's what a lot of students will, how they'll remember it. This is not focusing very well, so I can get that a little bit more in focus. So by using this rule, number 5, 4x quantity cubed becomes 4 cubed times x cubed. So this stuff right here, this 4x quantity cubed turns into that, which then simplifies. 4 cubed is the same thing as 64. And I just didn't write the multiplication symbol because you guys know that smushing means multiplication. So I've got this 4th root from way back here, and all I did was cube out this 4x all cubed. I just simplified this a little bit further. Now, how did I know 4 cubed was 64? Well, you can use the calculator if it's not something that you recognize, but it is just 4 times 4 times 4. Okay, so now let's go the other direction. Let's write some of these radical notation in exponent notation. So if I have the square root of x cubed times the square root of x cubed, I can so this is my original problem. I can rewrite both of these as x to the 3/2. Now what I did was I went back over here and I kind of lightly added those 2's. Those normally wouldn't be written there, but we know those are understood to be there because if there's no index, it's a 2. So each one of these becomes exponent over root, exponent over root. Now using property 2, I can add those exponents. So refreshing your memory here, property 2, these exponent rules, says if I multiply with the same base, I can add the exponents. So these have the same base of x, so I'm going to add 3/2 plus 3/2, which gives me 6/2 or just 3. So when you multiply with the same base, you keep the base, you add the exponents. Okay? All right. So let's look at a couple more here. This is 3 times the 5th root of x to the 4th. Be very careful, that's not the 35th root. That 3 is off to the side here, and as a factor, the root is only 5. So all I did was take the, right here, that 5th root of x to the 4th, and I rewrote that as x to the 4/5. The 3 is just along for the ride. it's not part of that radical expression, right? It's not under the radical, so it's not going to be raised to the 4/5 power. Now, why did I use 4/5 and not 5/4? Well, remember, it's exponent over root. Here, I did put the 3 under the radical. So how does that change things? Well, now the 3x to the 4th is all part of that 5th root. So my 3x to the 4th to the 1/5 power comes as a result of, grab a highlighter here, that 5th root is that 1/5 power. The parentheses are to tell you what all was under that radical. If I don't put the parentheses, then I'm saying, oh, well, only the x was under the radical. Here I'm saying, hey, the 3 and the x to the 4th were both under that radical. So let's do some that are a little bit longer. So we're going to simplify and write our answers in exponent form. I know I abbreviated that because I started running out of space. But exponent form as opposed to radical form. All right, so I'm multiplying with the same base. So I'm going to use rule number 2, or property number 2 here. Multiply with the same base, you add the exponents. So I'm going to have to add the 2/3 plus 1/5 plus 1/2. Use the calculator for that. You don't have to do that by getting a common denominator and try to do that in your head or side work or whatever. So these are going to be kind of tricky because you're going to have to know when to use these exponent rules, okay? So keep those rules handy when you're doing these. This one is division. So I changed each one of these to exponent form. So exponent over root, so 6/3, exponent over root, 4/3. I can simplify that 6/3 if I wanted to be 2, but I didn't, and I'll show you why. Because I'm going to use exponent rule number 3 here that says if I divide with the same base, I subtract the exponents of top minus bottom. So subtracting the exponents, 6/3 minus 4/3, I have a common denominator. So I got 2/3, which is right here. So that's why I left the 6/3. All right. This one, you can just straight up use the calculator. You don't have to do any kind of work. If there's not a variable going on inside there, then just use the calculator. You know? So don't forget the parentheses. So we got parenthesis, fraction, -8 over 125. Get out of that fraction, close the parenthesis. Exponent, -2 fraction 3. One thing I love about this calculator is this multi-view screen here. See, it's called a multi-view. This tall screen allows it to display everything beautifully. So it allows it to display it, just like it looks on your paper, and display the answer at the same time. So if your answer is wrong, you can go back and say, okay, did I type something in incorrectly or what? Okay then. Moving on along here. How about the 6th root of the 4th root of x? How do you handle multiple roots like that? Well, I color-coded it for you. So I first took the 4th root and I rewrote it as a 1/4 power. All right, so remember that? The definition of what it means to be the nth root is the 1/n power. So that one I just kind of tacked on the end here and called it rule number 9. So from here to here I'm using rule number 9 in these first few steps. So the 4th root became the 1/4 power. The 6th root became the 1/6 power. Now I've got a power raised to a power, so I'm going to use exponent rule number 4 that says I'm going to have to multiply those exponents. So I multiply 1/4 times 1/6, I get 1/24. Be really careful with these, okay? it looks like I'm just kind of willy-nilly doing this. You're like, okay, well, sometimes she adds the exponent, sometimes she multiplies. Well, it depends. Do I have one base and a power raised to a power, or do I have two bases multiplied together? So that's the difference in those rules. So that difference between number 2 and number 4 is that I have the same base. Here I've only got one base and 2 powers here. Alright, so let's look at example 5. Let's write our answer in exponent form. Alright, we've got the cube root of x squared times the 5th root of x to the 6th divided by the square root of x cubed. Let's change all of these to exponents. Remember, exponent over root. So exponent over root, 2 over 3. Exponent over root, 6 over 5. Exponent over root. Remember, no index means the square root, which means 2. So there's the 3 halves. I'm now going to use exponent rule number 2, and I'm going to add the exponents on the top. Okay? So exponent rule number 2 that I'm using is for that stuff. So multiplying with the same base, you add the exponents, you use the calculator. So then that top stuff simplifies to just be 28 over 15. So I kind of came down over here. Now to finish this off and to simplify it, just that one last step, this is now division, so I'm going to use exponent rule number 3, and I'm going to subtract the exponents, top minus bottom, 28 over 15 minus 3 halves. So just using the calculator for that one, so 28 over 15, get out of the fraction, minus, what was it, 3 halves? So 3 fractions 2, and get 11 over 30. So there's my final exponent for that one. This one used a whole bunch of stuff, right? We used the whole rule of how to change these radicals to exponent form, and then the exponent rules to combine all this into just one nice answer. Okay, so let's look at another one here. So I've got 16x to the 6th, y to the negative 4th, all raised to the 1/2 power. I'm going to use exponent rule number 5. That says if you've got a product raised to a power, that you can rewrite it as these power, this exponent, the product of those powers. So I can rewrite this and take this 1/2 here, and I can put it on the 16. I can put that 1/2 power on the x to the 6th. I can put the 1/2 power on the y to the negative 4th. So that's using exponent rule number 5. In doing so, I get what looks to be a heck of a lot worse than what I started with, but that's okay. For this one and this one, I'm going to use exponent rule number 4 and multiply the exponents, and I'm going to do that rule twice. So first, you can see I did that one in green. 6 times 1/2 is 3. So there's my 3. Here, negative 4 times 1/2 is negative 2. So there's my negative 2. And I just brought this 16 to the 1/2 power down. I can use the calculator to simplify the 16 to the 1/2 power. Okay? It's actually the square root of 16. It's just 4. So I'm almost done. I've got that's 4, that's x cubed, that's y to the negative 2. Hawks is going to ask that all of your answers have positive powers. So I'm going to use exponent rule number 7 to rewrite that as a positive exponent. Because this is a negative power in the numerator, I can move it to the denominator and make it a positive power. Now I know you might be thinking, what numerator, what denominator? Well, remember, if there's these are all the numerator of a fraction. You can write it as over 1. So all I'm doing is moving this down using this first part of rule number 7. So if you're not familiar with these exponent laws, I would highly recommend that you go back to the prerequisite sections in chapter 5 and you maybe rework some of those, right? Because that'll help refresh your memory on these exponent rules. Okay, one more. This is the cube root of a to the 4th b squared c all to the 15th power. And we want to write this in exponent form. All right, well, first let's get rid of the root. The cube root becomes this 3rd power, this 15 thirds power. That's because all this is to the 15th power, so this is exponent over root, because all this stuff under here is to the 15th power and all this stuff is cube rooted. So it's all this stuff to the 15 thirds power. I'll get to all this later, but for now, just taking note of these parentheses, how all this is to the 15th power, all this is to the cube root. Now I can simplify 15 thirds into just 5, because it's just 15 divided by 3. So that's the same thing as this. Then I can use exponent rule number 5, and because this is a product and it's all raised to the 5th power, I can use that exponent rule to say, okay, this is going to be a to the 4th raised to the 5th power, and then b squared also to the 5th power, and then c also to the 5th power. Now I put a 1 on here just to show you that it is a first power. It doesn't have to be written there. Then I'm going to use rule number 4 to multiply the exponents. So I'm going to multiply those and get 20. I'm going to multiply those and get 10. And I'm going to multiply that 5 and that 1 and get 5. So there's a lot happening here, okay? And I mentioned this earlier, but those prerequisite sections, 5.2a and 5.5 fit very nicely with chapter 9, and I really think that you would benefit from going back over these exponent rules and refreshing your memory before we add in all this radical stuff. So if you're struggling with the exponent rules, go back, redo these, especially 5.2a. Go back and redo that one especially, and then try your hand at, throwing in those radicals and stuff. But these two sections are going to fit very nicely with chapter 9. So, okay, that completes section 9.3 for us.